Yeah. Hi everyone. I'm Nikhil Lokhande and we will be talking about storage and querying in database management systems. So, database systems provide efficient storage and retrieval of data. This presentation explores physical storage systems, file structures, indexing techniques, and query processing. We'll examine how databases optimize performance and access large data sets. Let us start our presentation. So, first of all, we will be talking about physical storage systems. So, first let me talk and then we'll understand the hierarchy. So, primary storage. CPU registers and cache provide fastest access but limited capacity. RAM offers large capacity but volatility. So, CPU registers and caches provide uh, the fastest access to the data, but it has very limited capacity because it is cache memory. And but in primary storage, we cannot consider RAM because RAM offers a larger capacity than cache memory, but it has volatility. Secondary storage. So hard drives, SSDs offer high capacity and persistence. But hard drives and SSDs are have slower access compared to primary storage. When we talk about tertiary storage, then there we have optical discs and magnetic tapes that provide massive capacity. But they are the slowest to access between all of the primary and secondary storage, and they are used mostly for archiving data. So, moving on to this hierarchy of storage devices, we first have cache memory, then we have our main memory, then we have our flash memory, then we have magnetic disks, then we have optical disks, and then at last we have magnetic tapes. So, this is the hierarchy of various kinds of physical storage systems. Moving on to RAID storage system. So RAID storage system basically has a few features which we will talk about. So the first feature which we are going to talk about is redundancy. So RAID uses multiple disks to provide data redundancy and improve its performance. So multiple disks are used to provide data redundancy, and it basically improves the performance of RAID storage system. Stripping. So what happens in stripping? So data is divided across multiple disks for parallel access and improved throughput. So data is divided into multiple disks. So the same amount of data is divided across multiple chunks for parallel access of that data. So it increases it increases the improved throughput. Parity. Parity information allows data recovery in case of disk failures. So saving and storing parity information allows you for data recovery in case there is a disk failure. RAID levels. Different RAID levels offer varying trade-offs between redundancy, performance, and capacity. File structures. Let us understand different types of file structures. So the first one is sequential file structure. So what is sequential file structure? It stored records stored in sequence, simple but inefficient for random access. So what it basically means is in sequential file structures, the records are stored in a sequence one after another, and It is a really simple file structure, but it is inefficient for random access. If we have to access the data randomly, it is really inefficient. Heap. In heap file structure, records stored in any available space. If you have a chunk of available space, so the records are stored in any part of that space. It has the feature of it is very fast. It has very fast inserts, but the searches for the data are very slow. Hash file structure. Hash file structure uses hash function to determine the record's location. It has really fast access for equality searches. Indexed file structures. So index file structures have primary index, secondary index, and clustered index. So index on the primary key means primary index. It provides fast access to unique records. Secondary index. Index on non-primary key fields allows multiple search paths to records. Now, the third one is clustered index. It records physically ordered based on index. It improves uh, range query performance. Now, let us talk about single level indexing and multiple level indexing. First, we'll talk about single level indexing. Single level indexing mainly consists of primary index, secondary index, dense index, and sparse index. So, what does primary index mean? So, when the index is on the primary key field, it means primary index. It determines the physical order of records on the disk. Secondary index. Additional index on non-key key fields. It allows for faster retrieval based on those fields. Dense index. It contains an entry for every search key value. It provides fast access but requires more space. Sparse index. It contains entries for some search key values, saves space, but may require additional task accesses. Let us talk about multi-level indexing. B trees. So it is a self-balancing tree structure. It maintains logarithmic search, insert, and delete times. B plus tree. It is a variation of B minus tree. It stores data pointers only in leaf nodes for efficient range queries. Bitmap indexing. So, in bitmap indexing basically uses bit arrays for each possible value, efficient for low cardinality columns. So, bitmap indexing is efficient for low numbers of columns. It uses bit arrays for each and every possible value. Hashing. So we have talked about hash file structure. Let us understand how hashing techniques work. Hash function. As we have talked, hash function maps search key to a bucket address. So the search key to the input is is mapped to a bucket address and it enables constant time average case access. So the access or the search is really efficient and fast in hash function. Collision resolution. It handles multiple keys mapping to same bucket and uses chaining or open addressing. Dynamic hashing. It adapts to growing or shrinking datasets, maintains performance as data size changes. Query processing. So query processing mainly consists of firstly parsing. So parsing means breaks queries into tokens, performs lexical, syntactic, semantic analysis on the query. So next is translation. Translation basically converts past query to internal representation. It often uses relational algebra, optimizer. So in optimization, it generates efficient execution plan, considers indexes, join orders, and access methods. Execution plan. In execution, it runs optimized plan against the database and returns result to the user. Moving on to our next topic, query optimization techniques. So here are some query optimization techniques, their description and their benefit. Join reordering. It finds optimal join sequence and it is beneficial to reduce intermediate result sizes. Index selection. It chooses appropriate indexes, speeds up data access. Materialized use. Pre-computes query results and is beneficial for avoiding expensive computation. Query rewriting transforms query to equivalent form and it enables more efficient execution. Moving on, this was our presentation. Thank you for your time.